Hello, welcome back to Decaf-Math, and welcome if you are new here. So today we are going to play around with the idea that there is a standard for the order of operations. So this specifically applies for arithmetic. So specifically when we're working with numbers, but of course if you are learning other math, you can extrapolate the ideas from today, like in algebra, for instance. So the order of operations still applies. And all that means is we're going to focus on addition, subtraction, multiplication, division, and exponents. So hopefully we have a nice foundation for those. And then one more situation that we'll get into. So those are operations. So for instance, when you learn addition for the first time, typically you will just do something plus something. For instance, what is 2 plus 3? What is 2 plus 3? That is 5. Very good. So you'll just do one operation, just plus, between two numbers. Or you might learn what is 8 minus 4. And that would be 4. Nice. Very nice. And multiplication, same thing. 2 times 7. Might have a dot there. But 2 times 7 is 14. Very good. And then what about, let's see, how about 12 divided by 3? 12 divided by 3. 4. Very nice. And sometimes you might see that written as a fraction. So like that, or even a 12 over 3. All the same idea. Good. And then with exponents, 2 to the power of 5, like that, means what? Means 2 times 2 times 2 times 2. So 2 times itself 5 times. 1, 2, 3, 4, 5. So that would be 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Very good. So you see, for plus, minus, times, divide, and an exponent, typically we just do one of those operations, right? We just involve two numbers. So when we talk about the ordering, we're talking about situations where we combine multiple operations in one problem or in one expression. So let's say we have 10 minus 2 times 3. So you see here we have a minus and a times. So what does this equal? So the reason we need to have a standard is because, is this equal to 10 minus 2, which would be 8, times 3, which equals 24? And so I just put some question marks there, because do we do this part first and then multiply? Or does it equal 10 minus 6? So 2 times 3 is 6. And then 10 minus 6 equals 4? Question mark. So do we do this part first? Or does it equal something a little bit more strange? Is it 10 times 3 minus 2? So 30 minus 2, which equals 28? Question mark. So, or something really wonky. Who knows, right? And so it would be a problem if math is supposed to be about logic and we should be able to communicate to each other. There should be a standard order. So two people who speak completely different languages should be able to look at this and arrive at the same answer, which is why there needs to just be a general standard. So there is, and the correct order in this case would be this one. So we like this one. And so let's take a look at what that ordering is. Okay. So a very common acronym, maybe a mnemonic, don't really know which one's which, is PEMDAS. PEMDAS. And you might have heard this in school or, I don't know, maybe just around. But that is our mnemonic for the order of operations. So we have P, E, M, and I'm going to write the D over here. So I'm going to do M/D, and then A/S. But PEMDAS. And you might hear some kind of variation of this, but this is definitely the most common. PEMDAS. And so what this stands for is P is for parentheses. How do you spell parentheses? I think it's an E. Parentheses. E is for exponents. Exponents. M is for multiplication and division. So multiplication and division. And I'll show you why I'm writing it like this. And then addition and subtraction. And so what this means is we go from top to bottom in terms of order. So parentheses always come first. And that's like the one-off situation I mentioned earlier. It's not an operation per se, but if you put an expression in parentheses like this, rounded out parentheses, it tells you to do that part first. So you ignore the rest of these rules, you do that part first. And then come exponents. So you evaluate or simplify parts that have to do with the exponents. And then multiplication and division. So if I were to write P, E, M, and then D underneath, and then A, and then S, you might think that multiplication would happen before division, but that's not actually the case. Multiplication and division happen together, almost like on one layer, and you always evaluate from left to right. Left to right, but you simplify all multiplication and division parts together. And same for addition and subtraction. In one layer from left to right, okay? But here you could see after exponents would come multiplication and division, and then lastly comes addition and subtraction. Okay, so with parentheses, let's try one with parentheses. So let's say we have 3 plus 7 minus 2 squared plus 6 divided by 4. Wowee, right? Wowee. It's like opening up a whole new can of awesome. So, we just have to take it step by step, avoiding the temptation to always go from left to right, because that might be like our tendency to just to read it across and simplify. But we do just need to follow these steps in this order. So, we'll just keep this in mind. PEMDAS, PEMDAS, PEMDAS. And like I said, you might learn or hear a slightly different variation of this. PEMDAS is pretty helpful. So what we do is we look at parentheses. Do we have parentheses in this problem? Yes, we do. So the parentheses are basically like saying, hey, focus on me. Do this part first. Okay? So there might be stuff in this, and there might even be parentheses within the parentheses, in which case you kind of just work inside out. We can do more practice with this if need be. But we are doing everything inside the parentheses. And you might end up restarting this list again within just that. But it tells you this is the first layer we are going to work on. So in this case, we have 3 plus 7. So we evaluate that first. And 3 plus 7 is what? 10. Very nice. Okay. So we have 10, and if you want, you can just recopy the rest of the question again without touching it. Then you really have checked off the parentheses. Now, exponents. Exponents. So we look at, do we have an exponent? Yes, we have 2 to the power of 2, and that we're going to simplify. So this part equals 4. So we have 10 minus 4 plus 6 divided by 4. Okay, good. Do we have multiplication? No, we don't. But do we have division? Yes, we do have division. 6 divided by 4. And so I didn't pick a pretty number here, but 6 divided by 4. You could review your decimal work if you like. Let me know if you want to do that together. 1 times 4 is 4, and you have a 2, so you can put a decimal up here, bring down a 0, and 5. So 1.5, or you could have just done 1, and since there was a remainder of 2, you could put the 2 over 4, which is 1/2, which is 0.5. Whichever, we get 1.5. That's okay. So we have 10 minus 4 plus 1.5. And I did just kind of want to throw in a decimal there, just to emphasize that sometimes the numbers don't always work out pretty. Sometimes you'll get decimals, and we can generalize for situations like for exponents, when you have square roots, for instance, that's actually a special case for exponents. That would be an exponent of 1/2, for instance. So these pretty much cover our basic arithmetic situations, okay, even if it's in disguise a little bit. But the 6 divided by 4, we can work with our decimals, our fractions, and everything too, okay? So no need to be scared. If we have negative numbers, it all applies the same way. So now we don't have multiplication, we took care of multiplication and division. So if there were like multiplication here and division, we would just go from left to right for those parts for multiplication and division, okay? And so we'll have an example of that here. We have addition and subtraction. So we're moving on to this layer, and you see we have both addition and subtraction. So we don't have to do, and actually we don't do specifically, addition first and then subtraction. We just do them from left to right. So we do 10 minus 4, which is 6, plus 1.5, and that would be 7.5. Okay? And the reason really is that multiplication and division are actually basically one operation in a way, right? They're kind of opposites because division is the same as multiplying by a reciprocal, flip-flopping the second number, and adding and subtracting is almost like subtraction is like adding a negative number. So they're kind of opposite, and that's kind of why we just go from left to right, because you could rewrite them each as just one operation. So this gives us 7.5. Okay, so from there, just take your time to go layer by layer, and maybe I can come up with some more examples down the line. Of course, we can get more practice, and of course, if you want to review exponents some more and our basic operations here or decimals, you just let me know. So now I think we have our tools to help out our friend. 4 plus 6 minus 7 plus 1 minus 10 times 6. So I'm hoping that I copied their question down correctly and that they copied their problem down correctly. But either way, this is a good practice problem. So we have PEMDAS, so you can write this on the side of your paper. And so, do we have parentheses? Yes. So now that we know PEMDAS, maybe we won't be so tempted to go into this from left to right. And in fact, as you continue to get more practice, you will be more inclined to go for parentheses and exponents and jump straight to those first, and not so much look at addition and subtraction. So, do we have parentheses? Yes, we do. We have 1 minus 10 inside the parentheses. So this would be negative 9. So again, we have to be working and pretty comfortable with our negative numbers, but that's negative 9. And if it helps, you can always just rewrite everything, but with the part that you evaluated. And since we have a negative 9 here, just to be clear, I'm going to leave that in parentheses, but I don't mean that as in this kind of parentheses, because negative 9 is already a number. but I want to kind of separate that from the plus. So I don't have a plus minus 9. It's kind of odd. So I look next at exponent. I don't see anything raised to the power of anything, but I do see multiplication, but no division. So we'll just go straight to the multiplication. And what is negative 9 times 6? Negative 9 times 6 is negative 54. And at this point, you can do plus minus 54 if you want. Or you can go ahead and remember that plus minus means just minus. So you just go ahead and do a minus 54. And this plus minus part I know is a little bit strange. You can either sort of think of it as a secret plus 1 times negative 54, and a positive times a negative is negative. Or you could think of it as on a number line, if plus means moving to the right, then plus minus kind of, if it's a plus 54, it's 54 units to the right, but plus negative 54 kind of implies going left, negative 54. I don't know. It's kind of a strange concept, but I hope that kind of helps with the intuition about the plus minus thing. So at this point, we would have a 4 plus 6 minus 7 minus 54. Good. So now we don't have division or anything, and we already worked left to right. We just had our multiplication, and now we have addition and subtraction together. So we just go ahead and go from left to right. So 4 plus 6 is 10. 10 minus 7 is 3. And then a 3 minus 54, if we're comfortable with our negatives, is negative 51. And that's kind of surprising, right? It's kind of surprising, but it's because we're doing this part first, and then this part, and then here to here. So at first glance, it might not look like we're going to get such a negative number, but that's what we get. As long as we just follow our PEMDAS, we're good to go. So again, that's assuming that we copied the question right and our friend copied that question right. But I hope that this was a good little practice problem, and I think we've helped him out. So if you want to take a look at anything else, I'd be happy to. I'm sure this stuff will actually kind of pop up as we work through some algebra as well, especially when we solve one equation with one variable. The idea is actually basically we reverse PEMDAS so that we can isolate our one variable to solve for it. So it's just so that we can undo things one at a time. Okay, so anyways, I think we'll get more practice with it, but of course this also relies on us remembering how negative numbers work, how exponents work, and so of course don't worry at all. We're just gonna take a look at everything in a really relaxed way, and this isn't really about how much we know or don't know. It's just about hanging out here right now. So I hope that you are relaxed. I hope that this was relaxing, and if you happen to be asleep, I wish you sweet dreams, and thank you for hanging out with me, and I will see you again very soon.